Okay, I'm going to go through the investigation on page 180, showing you my solution. And as I talk about it, I'm going to highlight some things about setting out, because I know your teachers are anxious that you present your work a little bit better. So the investigation was about a mass vibrating on a spring, and you were given some data of the heights above and below a mean position with time. And the first question was to draw a scatter plot. So here's my scatter plot, and you notice that I've chosen a scale for time in the X direction, for height in the Y direction, and I've chosen a scale such that it takes up a reasonable piece of my paper. Graph should be at least a third to perhaps half a page when you're doing that. So choose a scale such that that happens. The other thing you'll notice is, and this should happen for all graphs that you draw, you have a heading. This one I've headed scattered diagram of an undamped spring. Secondly, the axes should be arrowed. Thirdly, they should be labelled as to what they're representing. Here, height on this axis, time on this axis. And also they should have the units on. The height is in centimetres, so I've said that there, and the time is in seconds. And another feature of that all graphs should have is that there should be numbers on each axis so you can tell what the scale is. So there it is, I plotted the data, and it has this sort of shape. The next question asked you why a trigonometric model might be appropriate for this data. Now, I found that pretty hard to answer, other than just saying that generally the overall shape seems like a sine curve that's been shifted. You could also say, yes, it's periodic, as a sine curve is. Also, it seems to be that this would be the data for a spring, because the way you would set the spring going would be you'd pull it down such that initially it has a negative displacement from its rest position, then it would move upwards, go past its mean position to a maximum, back again down to the bottom, and then that is repeated. So it seems like a sine curve would fit that pretty well. Next, you asked to find the amplitude. Well, the amplitude is the maximum displacement from the rest position, so you can see from the graph that it is 15 above, 15 below, so the amplitude is 15. Or the other way to work it out is the max, take the minimum divided by 2, so it's 15, take negative 15, which is 30, divided by 2 is 15. We can see the amplitude is 15. And that means if we're going to represent it with an equation like this, that the number here is 15, A is 15. In number 3, they ask you to work out the period. Well, one complete cycle is from here to here, and you can see from the scale that it is 1.2 seconds. So the period is 1.2 seconds. And from that, we needed to work out B. Well, we know that the period is 2 pi over the value B here. So if we put 1.2 equals 2 pi over B, we can do the algebra to solve for B, and it turns out that it's 5 pi on 3. So B is 5 pi on 3. Next, they said, show that the translation is pi on 2. Now, when I look at the graph above, I see that the from a basic sine graph which starts here and goes up, this point has been moved from here to here. In other words, the translation is 0.3. So I think the translation is 0.3 to the right, which means that C has the value of 0.3. So the overall equation that they asked for in question 5 is this one. So where did they get this pi on 2 from? What I think they were thinking of was if they'd asked you to find the equation in this form, h equals a sine bt takes c, where the c is not in the brackets, then if you think of expanding this part, yes, we get 5 pi 3t, which would be here. 5 pi 3 times 0.3, 5 pi over 3 times 0.3, we wouldn't expand that bit, becomes, well, 0.3 divided by 3 is 0.1, 5 divided by 0.1 is 0.5, so this is 0.5 pi, or it's a half pi, or pi on 2. So if they'd ask us for the formula or the equation in this form, yes, this number C would have been pi on 2. But actually the translation is 0.3, and that's therefore the value of C there. Question 6 said to find the height of the spring after 4.25 seconds. So that's just a matter of substituting 4.25 in here for T. And then you, if you do this on your calculator carefully, you get that it's 14.5 centimeters. Now, I said I was going to talk about setting out. Actually, this is not good setting out here. A little rule I have is that you should have only one equal sign per line. So this bit should come underneath here, and then your answer should come underneath that. I didn't obey my little rule there because I tried to fit everything onto one page. Question said, is the model realistic, or why would it be unrealistic? I said the model is unrealistic in that the amplitude would not stay constant, wouldn't stay at 15. As time went on, the amplitude would decrease as the spring lost its energy. And here's another little hint about answering questions like that. When you answer a question like that, you should first of all answer in complete sentences. And secondly, a good hint is to try and answer the sentence in such the way that the reader can understand what the question was. If you read these sentences, it's clear what the question was that I was asked. And lastly, I just drew a graph of this using Desmos just to see or to show that it did give or fit the data points that were given. Okay, hope that summary of that investigation helps, and try and take some note of setting out, and as you work day by day on exercises and in your assignment work, try and follow those little rules in terms of setting your work out.